Hello students, today you're going to take Cornell notes on the periodic groups 16 through 18. Go ahead and set up your notebook and we'll start in a few seconds. If the video is going too fast, please pause it or rewind it if you need to. You're in charge of creating the questions on the side, the summary, and the advanced question, aside from copying the notes. Okay, let's start. Okay, today in this video we're going to be talking about groups 16, 17, 18. So in this periodic table, here's 16, here's 17 and 18, so pretty much the right hand side of the periodic table. Okay, let's begin. First, let's start with group 16, the oxygen group. So oxygen group obviously includes oxygen, which is usually a gas at room temperature, but it can be also turned into a liquid. It has sulfur, selenium, tellurium, polonium, and livermorium. So it has 3 nonmetals, 1 metalloid, and 1 metal. In the outer electron shell, there's 6. They're usually very reactive. That's why there's H2O. Oxygen loves to bond to other things, and usually it can bond to water to create water. And usually they're solid except for oxygen. So for number 1, write oxygen group. Group 16. Solid at room temperature except for oxygen, and most of them are nonmetals. Go ahead and think of a question for 1, and then we're going to move on. Alright, moving on. Do you have a question? If you do, let's move on to 2. The halogens. Group 17. Halogens include chlorine, bromine, iodine. Remember, this is a very poisonous gas. They are nonmetals. They are very reactive, more reactive than group 16. Poor conductors of electric current, and they have violent reactions with alkali metals. So group 17 likes to bond with elements in group 1. And you never find them rare in nature. You can't just like go on the ground and look for bromine or iodine. Usually it's already bonded with something else. You have to break it apart to extract bromine, iodine, or chlorine. For example, here's the very violent process of making salt. So right here is chlorine gas, and you have the alkali metal sodium in here, and salt is made after the 2 react. So you can see that the reaction is very violent when a halogen meets an alkali metal. For number 2, write nonmetals that are highly reactive. Since they're missing only 1 electron, they're unstable and they just need 1 more electron, so they steal the electron from other atoms, other elements, and that's what makes them so reactive. Go ahead and think of a question for 2. Okay, moving on to 3. Group 18, the last group on the periodic table, are the noble gases. Include helium, neon, argon, krypton. All these gases are actually invisible. Radon is the only one that's not in gas form regularly out in nature. So anyways, these are gases, and they usually turn into plasmas when electrified because they don't need any electrons. Their electron shells are full. So if you give them more electrons and they don't need it, they actually release energy, or they glow. This is why the neon gases or the noble gases glow, because their electron shells are full. So when you see like all these neon lights, they are usually combinations of noble gases. So here are some facts that you need to know. They are nonmetals. They have 8 electrons in their shell, except for helium, which has 2. They usually don't react with other elements. They like to be by themselves. They are colorless and odorless, usually gases, except for radon, I guess. I said that earlier. Okay, noble gases, group 18. Non-metal gases that are colorless and don't react or mix with other elements, usually. And they usually turn into plasmas. Go ahead and think of a question for 3 when you're done. Okay, and for number 4, the last one, it's already on this picture. That's why I changed the picture, didn't have it. So you see the 10 is the atomic number, we know that. And this little tiny number here, that's usually called the atomic mass. The atomic mass is the addition of the protons plus the neutrons. Usually it's going to be the same amount of protons as neutrons, so 10 plus 10 is 20. And you can see this is 20.160. And then you find the average of the different isotopes. So that's why it's not a perfect 20, because if it has 3 or 4 isotopes, you find the average of that, and that's what gives you the atomic mass. Okay, when you're done copying the 4th one, start your summary and advanced question. And then don't forget to have questions on the left. Move on to step 2 when you're done. Have a good day.